Hi, let us start chapter 2, which is about functions. So, this chapter I have divided into this section 2.1, which about functions. I have divided it into 3 parts. The first part, I will explain the definition on what a function is and how we evaluate it or how we find its values. In the second part, I will describe what is a difference quotient and how we find it. And then the third part is about finding the domain of the function. So different kinds of function, how we find the domain. Section 2.1, in the homework also there are 2.1a, 2.1c, and 2.1b, and then 2.1c. So you have 3 homeworks on section 2.1 in online, in WebAssign. So that's how I have divided the sections over here as well. So section 2.1 A is about definition of a function. Well, you should be able to see that we see functions actually every day in our life, and we see that we are surrounded by functions. And what is a function? Function is actually a special kind of a relation, and relation happens when one quantity depends on another quantity. So you notice your height depends on your age, the temperature depends on the day of the year, the area of a circle depends on the radius of the circle, because what is the formula? It is A is equal to pi r square. Now pi is a constant, pi is a fixed number. So what it can change the area? The radius. So if radius is changed, area is changed, and so on. The number of bacteria in a culture depends on the time. So if you have, you start with, let's say, 4 bacteria. So after 1 hour, you can have certain number of bacteria, but after 2 hours, you have more bacteria. So the number changes. And in the same way, you can say that if people covered the same distance from one place to another place, the time speed depends on the time, or the time depends on the speed. So the slower the person moves, more time they take. So now, instead of the words depend, we will use function. Okay, dependency is actually kind of a can be replaced by function. So we say height is a function of age, temperature is a function of date, area is a function of radius, and the number of bacteria in a culture is a function of time. Okay, so a function, we now in our language, in mathematics, we can define it like a function f is a rule that assigns to each element x in a set A exactly one element y in a set B. So if you have a set A over here and you have a set B here, there could be some quantities here, and then so it assigns to each element here only exactly one element in B. So it cannot happen this is takes on it goes to this, or it is connected to this and it is connected to that. That cannot happen in a function, because this quantity must be connected to only one quantity in B. But this can happen, that you can have A is connected with this quantity up there. Some other element in A could also be connected to that one. So that is okay, but you cannot have from the beginning 2 arrows coming out. That's what we say. Okay, so what is the definition of a function? We can also think of it as a machine. We can say it's a machine that gets a function is a machine that takes in x the elements of A, which we also call them inputs. and then spits out the elements of B, another some set B, which we say Y. Okay, so this is another way of looking at the function. So the Y's are called the outputs. Okay, now note this thing, this machine. So if we say X is the input and Y is the output, okay, so one machine is giving me that. If I put X into another machine, it will again give me Y, but this Y could be different from the Y of the other machine, because, for example, if you put this machine as the X square machine, then what will happen when you plug in the number 2, this will give you 4. So if you in 2, if your input is 2, your output will be 4. But if in the other machine, depending on what the machine's name is, so let's say it is 1 over x, right? So now if you input 2, you'll get 1/2, which is different from the value in the first machine. So the Y, common name Y doesn't give us the specific values, or doesn't give us that this Y will be different from that Y. So in order to differentiate them, what we do is, instead of calling them Y, we associate them with the name of the machine. So we will say when X is the input, the output is going to be something like this, and we read it as F of X. Okay, F of X, or sometimes F at X. Mostly this is the more common one, so we will say it is the value of X, of F at X. Or another way of saying it is the image of X under F. Okay, under F. So we often say Y is equal to F of X. Our function is Y is equal to F of X. So if our machine is named G, then we will say our function is Y is equal to G of X. So this is called function notation. Now the set of points which are inputs, those are called, that's the whole set. When we collect all the inputs, that is called the domain of the function. The range consists of all the possible values F of X that are images of the domain values. So those form the range. So the images, or the Y values that were the images of the X values, are the range. When we write the function in this form, Y is equal to F of X, we treat X and Y as variables. X is called the independent variable and the Y is called the dependent variable. Now there are 4 ways to describe a function. One way is to write down to use a table or a list of values. So for example, I could use something like this: 1, 2, 3, 4, and then I get, these are my inputs, so the outputs are 1, 4, 9, 16, and so on. So what does that mean? It means what is the machine doing? What is the function doing? It is squaring each input. So we can call this the F of X is equal to X square function. So how would we define it now? Write it in the list like this, like I showed you. So you can make a horizontal what is table, or a vertical table. So that is how we can describe a function, by using a list. And then we can define it verbally, or using some words. So So we can say the square of the, so f is the square of numbers, square of numbers. Okay, third way that we can define is by a formula. Now this function that I have over here, f of x is equal to x minus 4 whole square plus 3. So this is the function we have used here and in all these examples. So how would you list it? By listing some of the values. We cannot list each and every value in the list, but we can list some of them. But it's hard to see from this list what is the equation of the function. So this listing type we do when we have very basic simple function. But when we have complicated functions like this one, we either use the definition or we can use the graphing method or the visual method or visual version of the function. So there are 4 ways. One is by listing, second is by verbal method or saying in words, using words, and third method is by using a formula, and the fourth is by graphing the function. So these 4 definitions or ways are shown for this function, and this is the graph of the function. Okay, now note here that not every equation is a function, okay, and not every graph represents a function. So when you have a graph, there is a special way to look at it, whether it is a function or not, which we will see in, I think, a few minutes, hopefully. Okay, then, so how do we evaluate a function? So how do we find the values of the function? So in the definition of a function, the independent variable x plays the role of a placeholder. So for example, the function f of x is equal to negative x squared plus 3x minus 1 can be thought of as f of something is equal to negative of something plus 3 into something plus 5. So wherever there are parentheses, there is some value to go in there. So if you notice, we have the parentheses in wherever we had x. So this one over here, negative x square, it does not mean that you will, if the x value is 2 and then you have a square here, notice that this will not be 4. This will be equal to negative 4 because the square is on 2, not on negative 2. If it is supposed to be on negative 2, then it will be in parentheses whole square, then it will be 4. Okay. So here is the example. So same function. So we have to evaluate f of 0, f of 3, f of minus 3, and so on. So if you notice, this is the same thing as if I am saying that if y is equal to, so if we give our function like with the y, then I can say y is equal to, let's see, why is it not writing? Okay, if we have y is equal to negative x square plus 3x minus 1, then what is the value of y when x is 0, when x is 3, when x is negative 3, when x is negative t, when x is 1/2, and when x is x plus a? So what will be the y value? So that's what we are doing. But we will not use that method. We will use this now new notation that we have learned. And by this quantity, you should understand that when we say find f of 0, okay, first quantity is f of 0. So f of 0 means what is the function value when x is 0. So this is how we will do it. We say f of 0 equals so it will be negative of, so that's why I will put parentheses, because remember we have a placeholder here. So you can start like this, plus 3 parentheses. There was a square over here, right? Don't forget the square. So every place you have x, instead of that we are putting parentheses. And now we plug in the value. So the value in the first case is 0 and 0 over here. So what will this give you? Well, 0 square is 0. So we get negative 0, which is 0, plus 3 times 0, which is 0, minus 1. So we end up getting negative 1 as our answer. Okay. So next one is f of 3. I'll leave it for you guys to try on your own. I'll show you about how to evaluate negative f of negative 3. So again, this will be negative of parentheses whole square plus 3 times parentheses minus 1. What goes into the parentheses? Negative 3. So negative 3, and now I do the calculation. Now negative 3 whole square is 9, but I have a negative sign out here, so it will be negative 9, and then 2 times 3 times negative 3 is again 9. So but there is a negative sign, so we get negative 9 and then negative 1. So I end up getting negative 19 as my answer. Okay, what about f of negative t? So same thing, negative of negative t parentheses within parentheses whole square. So there is a negative sign with the t, plus 3 into negative t minus 1. So this will be equal to, now the first term becomes negative t squared minus 3t minus 1. That is f of negative t. Now we had f of 1 over a, I believe. So f of 1 over a. And then f of x plus a. Okay, so f of 1 over a. I'll let you guys try to, let's see what you get. So I'll give you couple of minutes to work on that. F of 1 over a. So what do we get? Did we get 1 over negative 1 over a square? Negative 1 over a squared plus 3 over a minus 1. Did you get that? Okay, good if you got that. So how did I get that? Well, the same thing that I did before. So negative times parentheses square plus 3 times parentheses negative 1. Then what do? We plug in 1 over a here and plug in 1 over a here in the parentheses. So when I square the 1 over a, it gives me 1 over a square, and then there is a negative sign in front, so it becomes negative 1 over a squared. Now plus 3 times 1 over a. So 3 times 1 over a is 3 over a, and then negative 1. So that is what we get. The last one, same thing. So we have f of x. Remember, now in place of x we have x plus a. So f of x plus a will be equal to negative parentheses square. Now note here I am increasing the distance between the two parentheses because the beginning and the ending one, because I know a bigger value is coming in, plus 3 times the parentheses minus 1. So this gives me, I have to put x plus a here and x plus a over there with the 3. So now expand. So this is basically just, negative of x plus a whole square plus 3 times x plus a minus 1. So we can simplify it by expanding this term, then distributing this 3 over that, and then combining like terms. Okay. So the first expression gives me, I have to know what is x plus a whole square. I have to know that, right? So I can keep the negative out, and in parentheses I'll go on a side, multiply x plus a by x plus a, and find out what I get if you don't know the formula. So I'll get x squared so you get x squared plus 2ax plus a squared okay, so x and then a squared plus 3a plus 3x plus 3a. When I distribute the 3 over x plus a, and then we have minus 1. Okay, now I distribute the negative sign in front on the quantities, and we can see there we cannot combine any quantity because there is no two terms which are same or alike, but we will leave our answer is equal to negative x squared minus 2ax minus a squared plus 3x plus 3a the pen is really slow. Plus 3x plus 3a and then minus 1. So that will be the answer. Okay, I think this is the last example. Let me do that quickly. Oh no, okay, we have more stuff, so I will do it in the next video.